Good morning, welcome to Decoupled Days. I'm Dominic Laycock. I'm a co-founder at Mentrix. We work with clients that are going through system level transitions like decoupling projects, that kind of initiative. And previously I was head of content platform at The Economist. In fact, I was with The Economist for the entirety of its lifespan on Drupal. So some interesting times. Today we're going to be looking at the content platform, and this essentially came from an initiative at The Economist to try and decouple the website, but also to try and create a layer of abstraction in the middle. And we ended up having to do this primarily because we were trying to bring together content from multiple sources. So what we're going to look at are some patterns that I hope apply generically, regardless of the specific technologies that you're dealing with, that we can look at to shed some light on content systems in general and what some good characteristics of them are. And I think essentially what we're aiming for is a system that is easy to maintain and adapt as it changes. And generally we can think of that system, especially as content systems start to move into a space where they're no longer just one piece of software, but various different parts that are coming together into a system. So as the content systems get more complex, the way that we still ensure that they're easy to change is by making sure that these systems are loosely coupled. And we talk about decoupling a lot as extracting front-end code from an existing code base, but there are a lot of different types of decoupling. You can be coupled on time, not just code base. You can be coupled on platform. You can be coupled on the type of data that you're dealing with. All these are different ways that our software can become intertwined, and that makes it hard to change. So essentially, it's also a move from software thinking to system thinking. And we can see here on this slide some of the sort of changes in mindset that leads to. So from linear thinking to something more circular, from silos to something that's more emergent, meaning that the sum is greater than the parts. So the patterns that we're going to talk about today draw heavily from the journey with the content platform at The Economist. So in order to set some shared context for that, let's start with a story. So once upon a time, we decided to ditch our custom CMS and move to Drupal. And that was largely because there are a whole bunch of solved problems that come with using some piece of open source software. The Drupal community provides a whole lot of functionality that allows you to do more with less custom code. So great. So off we went to Drupal. And it's extensible, so we could do anything we want with it. And it was great as an engineer being part of that and just being able to plug in different things and configure and have great swaths of functionality available. So we add more and more, and it starts to have its own gravity. It becomes harder to justify building any one new feature somewhere else if it relies on something that we've already built in our existing Drupal site. So login tended to be the issue. You have an economist.com login. If we build a new section of the site and we wanted to build it separately, how do we integrate gracefully? So it kind of ended up being a vicious cycle of sorts. Drupal ended up being the answer no matter what the question was. At some point, we add some business critical functionality and it just cannot go down. So we add process. We look at more extensive code reviews and end-to-end regression tests. We look at zero downtime deployments and making schema changes in a way that makes it easy to roll back. Effectively, we've traded stability for speed. But this has an impact, and the front-end team are particularly crushed under the weight of this new process. They're caught between the desire for more and more interactive components on the web pages and a system that's now optimized for stability instead of speed. Elsewhere, product has also found its way around this process-heavy system. They're creating new sites and they're building apps, and they're choosing to do so in Drupal. So they create their own separate systems. But they can use the newest versions. That's a great advantage for them. And, you know, they don't need any process. They barely need a staging site. This is all beta. We can move super fast and be heroes, and everything's good. There's no integration needed here. The content that we're dealing with in the app is never going to appear on the site. Until, obviously, it is. And then how do we do that? Well, since it's a one-off, and it really is only a one-off, we're going to get the content production team to manually copy and paste that content in and maybe tweak it a little along the way. Just a one-off thing. Thus was born the human syndication pattern that just will not die. The front-end team found its own route. They did some experimentation on one of our smaller sites and were exploring building in React. And they got some great results. A really good looking site, very snappy, was wonderful. So great, we'll just decouple. That's the answer. But what about our now monolithic Drupal CMS? Does it just need a lick of paint and it'll all be good? Can we hide all the complexity now that we have a decoupled front end? Well, not really, because by now there's 2 newer versions of Drupal available, so we're in a situation where we're approaching end of life. So do we upgrade? There's about 450 modules at this point, and a lot of them are custom. So it's not a simple upgrade. It never is. Well, until recently, but how do we do that? Do we break up the site and create individual pieces? That was certainly our preferred approach. But more importantly, and critical for this story, is how do we bring back together all those disparate content silos? How do we enable product development to take, package, and repackage content as they want for any new product? So, yes, decoupling, but also with that layer of abstraction in between. And essentially, that is what the content platform was. That's what we're going to be looking at, is that middle bit between front ends, different products, different apps, different sites, and the back-end CMSs that were feeding content into that. So, what did the MVP of the content platform look like? What were we aiming for? We essentially knew that we wanted smaller blocks of code. We were going to go for a microservices approach. And this is a good thing for engineers, generally. It's easier to work with a smaller piece of code. It's easier to keep it all in your head while you make changes to it or deploy it. It's more predictable in how it's going to behave. A large system is a little more complex. But this isn't new to microservices. This has been the Unix philosophy since the 70s, to have modular pieces of code that you can compose together to do more and more interesting things. So, the other big driver was the ability to break that pattern of Drupal is the answer no matter what the question, and to be able to use the right tools for the job. So for a front-end team that is well-versed in JavaScript and wants to build very interactive UIs, they can choose to use React and Node and whatever else they want. For the mid-tier, we ended up using Golang to create microservices that gave us nice concurrency. But it was also a time where there was this explosion of tooling, because we were adopting continuous deployment patterns, and we were using AWS, and there was all sorts of new tools introduced at this point. So it was sort of a Cambrian explosion of technology tools, and the team really rocked it with getting up to speed with all those tools. But perhaps most important was the abstraction layer, hiding the implementation detail, so that when we're exposing content that comes from Drupal, we're not exposing all the Drupalisms that come with it. Good, you're still seeing the screen. Don't knock cables, is my advice. They're very finicky. So Yeah, hiding the implementation detail is a key aspect, and we don't want to expose something like field underscore rubric, whatever that is, underscore value. We want to expose rubric or headline instead of title. We want to be able to have a layer between the backend that can speak in a language that's a little more abstract. So, how did it go? Well, the abstraction was great. It gave us a pattern. It gave us a scaffolding around the Drupal site that allowed us to build this new decoupled front end without impacting the existing site, which had all this business critical functionality in it that couldn't go down. But it also gave us a way forward, an idea of how we were going to be able to pull functionality out of this monolithic CMS and put it somewhere else, because we already have that layer of abstraction sitting in front of it. It also really helped us to separate content and display logic. I'm sure you've all been in a scenario where someone said, hey, we have this new feature, can you just add a field to the Drupal content type? And sometimes those things are just pure display logic that really isn't content that's related to the actual content itself. So there was a lot of work within that initial MVP to separate out, to make sure that we're not exposing things that aren't really content related, and to try and learn collectively as now a series of decoupled teams how to work with this new system, how to work without needing to reach back into the database and grab information, or to put something that's very display logic oriented into a Drupal content type. And it was a big change for us. On what didn't go so well, well, these systems are really hard, and they're hard in a number of ways. Anytime you have multiple parts operating independently in a system, it's going to be harder to do things like consistent logging across them, monitoring, tracing requests as they go through the system, debugging in general, especially when you have teams that are responsible for different parts of the stack, becomes a little complex. Is it a back-end problem? Is it a front-end problem? Do we just kick it backwards and forwards across teams until someone decides to take ownership? So you need kind of a more system-level view, someone that's looking at the system as a whole and can then find out who the right people to talk to is. And coming from a CMS background, it's not surprising to know that when we thought about how the system would behave, it would be responding to requests coming in from a browser, generally, or an app. And that meant that each microservice was effectively a link in a long chain going all the way back to Drupal. So a microservice would take a request by a URL, for example, and would need to resolve, well, what is this? Is it a content type? What is its ID? How do I resolve that? And then another microservice would figure out, okay, so it's a node. What type of node is it? How can I figure out if this is an article or a blog and pass it on to the right microservice? And all that creates a fairly brittle chain. We didn't think a lot about how these microservices were going to interact with each other. So a lot of these things, as we start learning, as we're going through this process, are problems that aren't going to scale long term. Right, they got us the MVP, they got us the site we needed, we can iterate now, but we're seeing that there were some patterns that were not scalable, and there were problems. The blog microservice and the article microservice were probably 80% doing the same thing. So that doesn't seem super smart. So it also coincided with a new addition to the team who was a very talented architect by the name of Arthur, who came in with lots of new ideas about how he'd built a system like this before in the Telegraph. So it was a time of a lot of change, and that's where we start to see these patterns emerging. So we're going to look at 5 essential patterns that I think apply generically to content systems and help keep them nice and easy to change and adaptable. So the first pattern is canonical data. And what do I mean by canonical data? Essentially, I mean a unifying format. So we spoke before about how these microservices, for example, the article microservice and the blog microservice, were slightly different but mostly the same. Well, they produced a format that was slightly different but mostly the same, unsurprisingly. And that pushed the effort of having to figure out what kind of content am I dealing with to the consumers. So if you have 5 consumers, each of them have to figure out, is this an article or a blog, before I know exactly what the field structure is going to be. That didn't really work. And especially it wasn't going to work as we started adding not just different content types from the same Drupal CMS, but other content types, other sources, other non-Drupal sources, video, for example, or audio, things that didn't really have a content structure per se. So the canonical data model is an enterprise integration pattern that just basically says where you have multiple parts of a system, make them use a common language when they're talking to each other. And that is one of the critical things here. Another helpful guideline is to be conservative with what you expose and liberal with what you accept. And it's called the tolerant reader pattern, I believe. And that means if you expose stuff that comes out of Drupal raw, there's a chance that someone's going to start using some of that information, and perhaps you don't expect them to. Perhaps that information isn't really important. So be conservative with what you're exposing, and be liberal from a client point of view with what you're going to accept. And that way, when you make changes, there's less chance that things are going to break. But it's not just about content. We're also talking about relationships. And the canonical data model provided a really flexible format for creating those child-parent relationships. And it's called is-part and has-part. Is-part on an article would say, I'm an article that belongs to a print issue, for example, or maybe I exist in a number of curated collections. Perhaps I'm on a list, and it would be able to reference all those things. So someone that's consuming that content gets more of a sense of the context of it. Where is it being used? How can I add navigation or guidance to the reader to get them the information that they want? It also allowed us to do things like build a curation tool that operated within the content platform itself. So previously curation had been in Drupal, and that was fine. We can create a custom package of content, but we're limited to the content that that one specific Drupal instance knows about. And what we wanted to do was to create a much richer package of content that included audio and video and content from different sites and different apps, and combine them all together. That was one of the building blocks for new product development, in fact. So the ability to pull this a layer above the individual CMSs and to do it on top of that canonical data format meant that we had a place to move capabilities that were critical to work across multiple sources. And you can think about the generation of lists as one of those kind of capabilities. Other things like semantic tagging, for example. You want your semantic tagging to be across all your content types. If each of your individual sources of content has its own category for content, then what you're going to end up with are terms that only apply to specific contents, and it's almost like the content from those silos comes out still in its siloed shape and nothing breaks it, and there's no interdependency with any other content. So having something like a semantic tagging service at the platform level that runs across all types of content really helps build those connections between different pieces. So, canonical data. Essentially, a structured, unifying format that's common to everything in that one platform. And a foundation upon which to build. You can imagine we've built this semantic tagging service that is consuming canonical data. And then we're going to plug in another content source. That semantic tagging service is going to carry on working for the new source as well as all the existing content, because it's been built to expect content in that canonical data format. So it means that your services don't need to all change when you plug in a new source of content. And that was really critical for us. The next pattern is about breaking the dependency with the CMS. And I said before, we had this request-driven approach to the original MVP platform. A request from a client would trigger all these actions all the way back through the stack. And yes, we can cover it with caching to make sure that it is responsive enough and that we're tolerant in some ways to failures. But irrespective, as long as there is that fixed chain going all the way back through the system, an outage of your database, be it MySQL or whatever you're doing at the back of Drupal, can potentially have knock-on effects all the way up the stack. And likewise, a problem in one of the clients can have a cascading failure all the way back through the stack. So they don't have a lot of isolation. They're coupled in time, and also it's a form of coupling in control. You have a system that needs to know what each step of the journey is to be able to fulfill a request. And that's not very flexible. So we moved to a event-driven process. So you can see that here. The authoring sources, so in this case that would be a Drupal site. Something changes there, a piece of content gets created or edited, and an event gets fired. And the content platform is going to react to that and say, okay, I see that there's this ID and it's a change event, or maybe it's a created or an updated, and it's going to go back, request the content, and store it within the content platform. That is all that one thing is going to do. And we call that a worker. So we have a queue, and messages are going to go on a queue, and a worker is going to take messages from that queue and do something with it, and then that's it. It doesn't have any more awareness of what's going on around it in the system. In effect, this is a version of separating reads and writes. So reads, in this case, are still coming in, they're still hitting GraphQL, but they're not going all the way through the system. They're going as far as the content store, where effectively we have pre-built the content ready for it to consume. And the content store in our particular example was S3, which means it's super scalable and super reliable.
So you end up duplicating the content onto the content store for the purposes of reading. So they're read optimized in some shape.
Yes. And because S3 has a series of integrations with things like the notification service in Amazon, SNS, the act of storing a piece of content triggers, or can be configured to trigger further events. So I take a new piece of content as a format worker. I know that my queue is over here, and I'm going to take that, and I know I have to go back to a specific source, grab the content, store it. And then off the back of that event, the canonical format worker would kick up, and it would translate that content into a nice structured canonical format. Again, dropping it back into S3, triggering more events, so things like the semantic tagging worker and every other worker could react to the fact that, hey, something's changed in the system and I have something that I need to do, but again, I'm doing it autonomously, I can do it in parallel, I'm not coupled on time, I don't need to know what every other service is doing and how I am going to interact with it. All I know is I'm taking canonical data content and I'm going to do something with it and store it back as a payload in S3. This, honestly, was probably the biggest change to the content platform. It gave us a really simple pattern to be able to repeat for multiple services. It gave us a lot of flexibility. We can add new services in without having to change anything else around them. So it was greatly improved, and this kind of system isn't like the request-based system was orchestrated, controlled. This kind of system is more a choreography. There's things happening, but there's no one central piece that's managing what exactly is happening when. And that kind of choreography is a characteristic of a loosely coupled system. The benefit is you also have better isolation. Right? So if your worker is down, say the worker that's going to translate all this content into canonical format, if it's down or unavailable, messages are going to sit in the queue until it's back. Content that it's already created is already in the content store, so that's getting served, there's no problem. So there's more isolation between the different parts of the system. The blast radius of any one thing failing is a lot lower. So it's a really powerful pattern. But where does all the complexity go? That brings us to our next pattern. The complexity, as you add more and more parts to the system, goes to the connections between those parts. That's fairly logical, right? If we have a whole bunch of code in one part, then there's a lot of complexity within that part, but it doesn't have to worry about what's going on outside it. If we add multiple parts, now we have a situation where we have still some complexity in the individuals, but also complexity in how they're going to interact with each other. As you scale out a system and add more and more parts, the complexity is going to go up in line with the number of connections. So if every part of your service has to talk to every other part of the service, it's an awful lot of complexity to manage. That's why the event messages and the queues were such an effective pattern for us. But there's still complexity there. We're using what is effectively an enterprise integration pattern, and that's great because it means that there is other software that is already going to have solved those problems. Cloud providers tend to align pretty strongly in their services to integrate enterprise integration patterns. So it means that there's the opportunity for us to offload some of that complexity to a cloud service. In this case, it would be Amazon SQS. So that's the queue service, one of Amazon's oldest servers. It will do all manner of things for us. It will allow us to specify how many concurrent workers can pull from it, what the default timeouts for messages are. So if a worker just doesn't really fail but doesn't respond either, how long before we add that message back to the queue and retry it? How many times do we retry? What happens if we reach the end of that? What happens to a message that is permanently failing? Dead letter queues, all those kind of things are just configuration options within SQS. So, great. What we care about and what we maintain is the business logic that is in the individual workers. And the rest of it is configuration that we do within AWS. And that's not to trivialize it, there's still complexity there, but we're not maintaining any code. We don't have to do a code release if we want to change the concurrency of one worker to improve the flow of content through the system. This was probably the second biggest change, and this is the point where we stop building a system that happens to be in AWS, and we start building a system that's really leveraging the solved problems that are already available. So it's really leveraging Amazon services to be able to do parts of our system without us having to carry the maintenance effort. And yeah, like it or not, this is cloud native. The next pattern is designing for change, and we already said at the outset we want these systems to be flexible. That's why we're doing all this loose coupling. And the loose coupling comes at a price. There's some added complexity there. So, we want to be sure that we can take advantage of that and that our systems can evolve. Because cloud services themselves evolve over time. When we started implementing the workers, we were already using Golang. We knew we wanted to integrate with queues, and that put us in a space where we'd be looking at containers. But over time, some of those capabilities started to shift. and they became offerings that were also available for Lambda, for functions as a service. Things like native support for Golang, or the ability to control concurrency. Super important if you're going to have a worker that's going to respond to events. If 1,000 or 1,000,000 messages end up on a queue, you're going to want some kind of, hey, let's maybe process these one at a time kind of thing. So it got to a point where we were building a new worker and someone asked the question of, hey, why don't we use Lambda for this? And there were no longer any impediments for us to do that. So we started looking at it. What would it look like if we turned the content platform services serverless? And what we found was, because we'd encapsulated the business logic so well within those containers, because there was none of the kind of code that would be looking outside itself to the system and knowing how to interact with different pieces. It was just pure business logic. And that meant that we could shift it from a container to a Lambda function with what I think were a couple of lines of code change. And yes, there's a lot of configuration change to make the queues now feed Lambda functions and that kind of thing. But essentially, we've gained the ability to change where our code is implemented, how it's implemented, what patterns of behavior it's going to exhibit. And we've done so at a very low cost in terms of the maintenance for us. So that is our code, but what about our data? Is there a way that we can make sure our data is also portable? What we implemented within the content platform, aside from the canonical data model itself, which was based on schema.org types, is, well, let me back up. We implemented them based on schema.org types for exactly the reasons that we were aiming for in the first version of the content platform. In that MVP version, we wanted that abstraction of terms, that more generic language to talk about content regardless of where it came from. But we didn't perhaps go far enough. Aligning to schema.org meant that we had to think, for every piece of content, is there a way that I can express this in one of schema.org's types? So something like field underscore rubric underscore value, which got renamed to value in our first MVP, became description. Because a rubric, in editorial terms, is essentially a description. So it forces us to use these terms that are more generic, and that really improves the ability to reuse our content, because a client is no longer just expecting a client no longer has to know a whole lot about the content before it makes some decision about it. It can expect that there's going to be a description and a title and a subheadline, any of those kind of things. But beyond that, I spoke before about implementing a semantic tagging service, and we specifically looked for a semantic tagging service that would offer content, that would offer its data back in industry standard formats. And those were Wikidata, for what you would normally call entities within semantic tagging, so objects, people, places, that kind of thing. And topics from IPTC, which is essentially a standard for categorizing news, so a hierarchy of news topics. And because we had our data in that format, not only did we have that consistency of it working across all sources, but if we needed to change the semantic tagging provider at some future date, we can look for another semantic tagging provider that also adheres to these industry standard formats and switch without having to do a massive data mapping process. So that pattern of always trying to use an industry standard format protects you in a way. It gives you more ability to move the things that are yours, the data. And we continued to push that pattern as we built more and more services. When we were looking at transcription, one of the things that stopped us for a while from being able to fully implement was the lack of availability in AWS Transcribe of an industry standard format. It was all custom. And if you're using a custom format, then there's more chances that you're locked in. You're kind of coupled to that particular service. And we don't want lock-in. We want to be able to change our tools if there's a better tool available in Azure or in GCP. I want to be able to move my service over there. And if I do those two things that we've spoken about here, about making sure our logic is really well encapsulated, and that we're not muddying business logic and implementation details or technical code about infrastructure, and keeping our content, our data in industry standard formats, I think go a long way to helping ensure that you can re-implement your system elsewhere and avoid a lot of the vendor lock-in fear. Aside from the actual technology changes, though, there was a lot of the softer changes, a lot of organizational shift here. We're creating essentially a system that is a collection of parts that operate autonomously, and the sum of those parts is the whole is greater than the sum of the parts. And that's what we mean by emergence. The team also reflects this, and this is Conway's law essentially. The communication patterns of an organization will be mirrored in the systems they produce, and it is unnervingly accurate. So we want a team that is autonomous, not just a system that is autonomous. We don't want a lot of hierarchy or control, someone having to say, you go over there and do this and then do that and then hand it off to that person. That was kind of like the microservices approach, where everything knows the next link in the chain. We want a more fluid choreography. We want a system that can work independently in an autonomous way, and that's what we wanted for the team. And that involved a lot of cultural shift as well, and standing up for this process. A transition to systems thinking, and a transition away from some of the patterns that we were used to. It was common to get requests for change coming through that would talk about, we need a field added to Drupal. And at the point where you're now a decoupled app or a decoupled site, specifying that level of granularity of what a change should be doesn't really make sense anymore. We have a whole platform in between that is abstracting away some of that specificity. So changing those conversations from how conversations into let's talk about what it is you're actually trying to build here and how we can deliver that with this new platform, and make sure that we're doing it in a way that prevents us from creating those bits of coupling that tend to sneak in, because that's the way you've always done it. One of the ways that we did that was with top-down elaborations. And this is something that Diana introduced into The Economist. And it's just essentially a way of structuring a conversation, guiding us towards making sure we've covered off why is this important, why are we doing it, and what exactly is it that we're doing, and who's going to be impacted by this. And then we get on to how it might be done. And it also gives us the opportunity to structure who needs to be in the room for these conversations. If it's a conversation about how, I expect the engineering team to be in the room, because they're going to be building it. I'm not going to make commitments for them that then they have to just deal with, because I said that that was the way it was going to be. So I can have a why conversation, and I can have a what conversation. And my engineering background often takes me towards a how conversation, because that's super interesting. But at that point, I can bring in other people. And when? Not, this precise date, but how many things are ahead of you in a roadmap of work that we need to do, evolve this platform, where do you fit in, how does that work, how do you get into that queue of work, all those kind of things. On the how conversations, something that emerged really quickly was collaborative modeling. And we would see that there would be big differences between how an engineer thinks about what is available in the system, how the platform owner, how the architect think about it. Often those would be three entirely different stories. And the quickest way to get some alignment there was to do some modeling. And I don't necessarily mean diagrams and UML and whatever else. It was often just, let's get around a whiteboard and sketch this out. And it's really fast. And just take a picture of it and upload it to wherever you share information. Hopefully, like in some of these cases, some enterprising soul converts it to UML for you. Great. So the ones that we ended up finding most useful were the sort of sequence diagrams on the top right, which is how a request is going to go through a system, what's going to happen. Very useful for crystallizing in your head, particularly as these systems become more complex and have more moving parts in them. It becomes increasingly hard to keep it all in your head accurately. So just model it out. So these are the things that made a huge difference for the content platform. And I hope they are new ways of looking at a system that you might be working on or thinking about building. Not necessarily prescriptive, just, hey, these are some patterns that might be affecting your system, some things you might want to consider. But, you know, there's no one-size-fits-all solution here. Every organization is different. There's different technologies and business goals and people and whatever else. So there is always room for some uniqueness. And that's part of why we at Mentrix find these challenges so interesting, because the patterns seem to hold true even though the specific contexts are wildly varying, and it makes them super interesting. So if you have experiences of your own with these kind of systems, if you think they strengthen these patterns or maybe add another aspect that these patterns haven't reflected yet, I'd love to hear about them. Aside from anything else, it gives me more of an opportunity to geek out about the specific implementation details. So I'll be here for the rest of the day, and I think we have a few minutes for questions. Shoot.
So coming from the sort of the traditional way the Economist site was built, there must have been concerns about the previewability of content.
Yes.
By the authors who would be authoring it. And
Yeah.
this is like, you know, we run up against it all the time.
Yeah.
So what are your thoughts on that?
Avoid that question.
Yeah.
As much as you can.
Yeah.
It's
But
a
among
really
friends.
yeah, right. I had a strong reluctance to preview because conceptually I can't see a clean path to implementing it that's reliable, that doesn't force you to maintain an illusion of what that medium is going to look like. And it preserves us in a pattern of thinking about something expected. And what I really want is for the content that we're producing to be available for any product. Not just the ones we already know about, but the ones that are coming down the line. I mean, how do you preview something that doesn't even exist? So I don't think it's necessarily a scalable approach to have an editor preview in every single device that it's going to go to. I mean, how do you preview something that's been sent to Apple News or something like that? It gets increasingly tricky. So my experience is stay away from it as long as you can. Focus on getting the content semantically or neutrally displayed so that you can say, hey, does this look right independently of device? And then let's see how, when we add it to specific consumers, to specific devices, how it looks there. And some of the details that I had to skip over in the interest of time is a lot of these services that we built are doing things like formatting content for Apple News and pushing it to Apple News. And an editor doesn't know what that's going to look like until the moment it actually appears in Apple News. So it's really important from a system point of view of making sure it's quick and expedient if they need to remove that. So that means that your integration point is less likely to be something passive like a feed and more likely to be something like an API integration, where in our example we have a push worker that pushes to Apple News' API. So we can push deletes very fast. And that helped us to get around some of those what-if conversations. How do I preview it before it goes anywhere? No, it's going everywhere. And that's content systems these days. It's increasingly multi-source and multi-destination, and content goes everywhere. So this is why some of these patterns seem especially relevant.
So have you shown editors like the schema that works, say, preview of the content? Is that something that's scary?
The ones that are most technically minded, that are interested in that kind of detail, they don't really know that it's going to be in schema.org or need to know. They can still create content wherever they're creating content. We do a lot of the mapping of this field in this Drupal CMS maps to headline, whereas an audio file that's uploaded to the system that gets processed would use, I don't know, maybe the title that's in the metadata. So it's not always apparent to what's sending the content how it's going to be mapped. That's something that existed within the platform.
How was it mapping? So I saw there's GraphQL, so GraphQL is querying S3. Was that challenging at all, or is it, how was that?
Yes, is the short answer. The long answer is S3 is wonderfully scalable.
Yeah.
It is in an eventual consistency pattern, which means that you're not going to be able to write back to the same file. So if you have one worker that is picking up the canonical data and making a, let's say it's doing the semantic tagging, it needs to write that data back to S3, but in a different file, in a different payload. And what we do is within the main payload, we store references to other files, other payloads that we know at some point are going to come in. So you can imagine there's a lot of complexity in the platform with composing all those back together, especially when you start dealing with, parent-child relationships and how many levels of composition do you use. So yes, infinite capability for complexity there. Go ahead.
When you're writing the S3, what are you actually writing? Is it a buried thing? I mean, are you talking like...
It's just JSON. Yeah, just a raw JSON object. Go ahead.
The mapping stuff, so you have the Drupal 7 or 8 sites.
6, actually.
Okay, that's shows stuff, how this works. The mapping is being done in the content platform and not in Drupal 6.
Correct.
In the microservice.
Yes.
That's great. And then, I understand the concept of not storing display information in the content repository. So Drupal 6 is still maintaining, the Drupal instance is maintaining how this blog post should be displayed or rendered or what. Is there any thoughts on how you could share that display? Are you sometimes sharing that display information?
During the MVP period, the answer was, we are not exposing that information. You have to store it in the front end. It's front end code. It lives in the front end. That was not a popular value for us to live by, because it meant that there was a lot of technical debt that got pushed to the front end. So the answer, which was the perpetual answer, was we need a configuration service. And a configuration service is going to give you the ability to adjust a payload for a given consumer. Maybe one consumer wants the paywall to be after 3 articles, or a specific article to be free on its platform and another doesn't. Or maybe wants a custom headline, those kind of things. So that's where that conversation led to. How can we build this in a way that isn't specific to one client, but does allow a client to say, hey, I need some way to say, I want to disable comments on this piece on my particular front end.
What was your GraphQL server?
What was it?
Was it just a node server with GraphQL?
I don't actually remember. That is a good question. Go ahead.
How did you handle listings of content or aggregates?
Yes, the other one. So list was the biggest problem with the microservices. You can imagine a print edition page, which is once a week for the Economist, has about 90 articles on it, and is always going to be uncached when you publish it. And at that point where you're most interested in making sure it looks right, it is woefully unstable because hundreds of requests are being made through the content platform, and for all those to get cached takes some time. With the canonical data, that shifted a little bit because we had the ability to create a list in advance and publish it somewhere. So we would do that for something like feeds. But a more generic list capability came from Elasticsearch. So all the canonical data would be fed into Elasticsearch, and we could have that referencing happen at the API gateway layer to say, this particular item is associated with this list, so we're going to go ahead and pull that list from Elasticsearch and offer it to you. So, short answer, Elasticsearch.
Is that how you did search on the site? Or was there search on the site?
Site search was not using Elasticsearch, though that was probably the way we were headed at the point where I left, so yeah.
I'm currently kind of running into a problem with a similar kind of architecture around Elasticsearch and pushing updates to Elasticsearch and making sure those aren't pushed before content is live.
Right.
So you had to deal with that?
Yes, for sure. Lots of complexity in Elasticsearch, especially around storing lists in the right kind of order. So probably more than we have time to go into today. I'm cognizant that the next session will probably be starting soon, so we're gonna wrap.
Can you post your slides?
I can, for sure. Yes, I will post the slides.
And the poster slides would be on the conference site?
That I don't know, but I'll ask around, and if not, I'll tweet them out.
Thank you.
Great. All right. Thanks so much, everyone.